Welcome to my Artificial Intelligence Through Artificial Intelligence YouTube channel and the Introduction to Deep Learning and PyTorch course. In this session, we will explore the role of weights and bias in neural networks. First, we will understand the literal meanings of weights and bias, followed by their explanation with a real-world example. Then, we will define these concepts in the context of deep learning, and at the end, we will differentiate them.
That sounds interesting. To start, what do weights and biases mean in the real world?
Good question. Let's begin with weights. In everyday life, weight refers to the importance of something. For example, when buying a car, you might give more weight to fuel efficiency than to its color.
So, weight is like assigning priority to certain factors based on their importance.
Exactly. Now, let's talk about bias. Bias represents a tendency toward a specific outcome. For instance, a politician might only share articles that align with their views while ignoring contradictory opinions.
I see. So bias influences decisions regardless of actual data.
Yes. Now let's explain weights and bias using a real-world example in an artificial neural network. Suppose we want to predict house prices based on two features: size of the house, number of bedrooms.
How do weights affect this prediction?
Weights determine how much each feature contributes to the final prediction. If house size has a bigger impact than the number of bedrooms, it gets a higher weight.
Can you give an example?
Of course. Suppose our model assigns a weight of 0.8 to the size of the house and 0.2 to the number of bedrooms. This means house size is 4 times more important than the number of bedrooms when predicting price.
That makes sense. But what about bias?
Bias acts as a baseline price, accounting for factors not included in the model. Even if both inputs, size and bedrooms, are 0, the model still predicts a price.
It means that bias value will always exist.
Exactly. For example, if the bias is 50,000, and both inputs are 0, the predicted price will still be 50,000.
So, the model always makes a prediction instead of returning 0?
Yes. Now, let's define these terms in deep learning context. Weights are numerical values that determine the strength of connections between neurons. They amplify or reduce the importance of specific inputs.
And these weights are adjusted during training to improve accuracy, right?
Exactly. During training, the model fine-tunes weights to minimize the difference between predictions and actual values.
What about biases in deep learning?
Bias is essentially constant, and unlike weights, these are not connected to specific inputs but are added to the neuron's output. Bias serves as a form of offset or threshold, allowing neurons to activate even when the weighted sum of their inputs is not sufficient.
That means they introduce a level of adaptability that ensures the network will always learn something and make predictions effectively.
Correct. Lastly, weights and bias can be differentiated with several aspects. For example, with respect to definition, Weights are numerical values that determine the strength of connections between neurons. Bias is an additional parameter that shifts the activation function. With respect to role, weights controls the influence of input features on the output, whereas bias adds flexibility to the model, allowing it to fit data better. With respect to mathematical use, weights are multiplied by input values. Bias are added to the weighted sum of inputs. Objective, weights determines how much an input contributes to the output, whereas bias ensures the output is not zero when all inputs are zero. Adjustment, weights are adjusted during training to minimize error. Bias is adjusted during training to improve model accuracy. Example of weights is, if input X is 2 and weight W is 3, weighted input will be 6. In case of bias, if weighted input is 6 and bias B is 1.5, total input will be 7.5. With respect to association, weights are found between neurons in different layers, whereas bias is linked with each neuron in the hidden and output layers. Visualization, weights are represented as arrows between neurons with associated values, and bias is represented as an additional input, usually +1 to each neuron. That concludes today's module. Any questions?
No questions. This explanation really helped.
That wraps up today's video. I hope you now have a good understanding of weights and bias in deep learning. If you found this helpful, don't forget to subscribe, like, share and comment to stay updated with this series.